Hi, my name is Libby, and this is my Sudoku Solver project, an effort to apply an optimization algorithm I learned from CS50AI with Python. This program solves 4x4, 6x6, and 9x9 Sudoku puzzles using a Constraint Satisfaction Problem approach, or CSP. It models Sudoku as a formal AI problem and applies arc consistency, backtracking search, and heuristics to find the solution more efficiently. This is an upgrade to my last Sudoku Solver project for CS50 Python, which only handles easy 6x6 Sudoku puzzles. The project is organized into four main components. First, the file manager class handles input and output. It reads from a puzzle file and converts the grid into an internal data structure. And when a solution is reached, it prints the solution on the terminal and saves it to an image file. Second, the Sudoku puzzle class represents the structure of the puzzle. It stores the grid, the size, the box dimensions, and it dynamically computes the box index for a given cell. Third, the Sudoku CSP class translates the Sudoku puzzle into a constraint satisfaction problem. It defines the variables, which are every cell in the grid, the domains, which is a dictionary containing possible candidates for each cell, the neighbors, also a dictionary containing all neighbors for each cell. By neighbors, we mean all the cells in the same row, column, and subbox other than the cell itself. And the constraint function, that is, two neighboring cells cannot share the same value. Finally, the CSP class that handles AC3 and backtracking. This is a reusable CSP framework that could be extended beyond Sudoku. Now here at my code space, these are what's inside the Sudoku project folder. We have the puzzles folder, which contains the input puzzle files. Next, we have the csp.py, which contains the CSP class. The data.io.py, which contains the file manager class. The Sudoku csp.py, which contains both the Sudoku puzzle and Sudoku CSP classes. And here we have the Sudoku solver.py, which is the main file. As we can see here, first it imports the puzzle grid from a file, then creates Sudoku puzzle, then transforms that puzzle into a CSP problem, then solves it. If the solution is empty, it prints no solution. Otherwise, it prints out the solution onto the terminal and save it into an image file. The core solving logic happens inside the solve method of the Sudoku CSP class. First, it creates a deep copy of the domains. Then it runs the AC3 algorithm. AC3 enforces arc consistency by removing values from domains that violates constraints with neighboring variables. If AC3 determines that no solution is possible, the solver immediately stops. If the puzzle remains consistent, it proceeds with backtracking search to assign values systematically until a solution is found. So let's try to test the solver. We submit this command and the program outputs the solution grid into the terminal. And here is the image file also containing the same solution. Thank you for watching.